Welcome back to lesson number 2. Today we are talking about sound waves and audio signals and how we go about using these to make tracks. Alright, so when you record something, this is called raw audio. Then what you do is you manipulate this sound and achieve your master cut. So you're going to use something called signal processing, mixing, and mastering techniques. These separate audio signals you're creating are called tracks. So for example, if you recorded the guitar and then on your DAW you're going to see one track with all these little squiggly lines that are sound waves. And then if you record a second track with your vocals, let's say, you're going to see different little sound waves and squiggly lines. So what's going on with these squiggly lines? What are these? Let's figure it out right now. The first big term of the day is transduction. That's the conversion of one type of energy into a different kind of energy. So taking something, changing it into something else. And how do we do this in music? Well, we do this with things called transducers, such as microphones, headphones, and speakers. Now, a microphone is an item that takes acoustic energy, so what I'm making as a sound right now, and then it gets all changed up inside the microphone and turns into electrical energy. But now on the opposite end, electrical energy that was made comes back out from your headphones and your speakers and turns back into acoustic energy. And then this energy is different depending on the type of microphone you used, which is something we are going to explore likely in lesson 3 or 4. And then we're also going to be talking about how they hear different frequencies, which we're also going to talk into lesson 3 or 4. But we're only at lesson 2. So what are we talking about today, Mr. T? So what we're looking at are sound sources. All right, so more specifically, we're going to figure out what is going on with these sound waves, or what recordists would call waveforms. A sound source is a vibrating physical object, as sound waves that we can't see, but there are many different kinds. Some of them that go like this, some of them that go like this, and then there's all these kind of weird different lines, but we're going to take a listen to know what these different sound sources sound like and where they come from. So first things first, the horizontal sound wave just represents time. How long are we hearing this sound for? Now the vertical part of the sound wave are the changes in air pressure. These changes in air pressure are called amplitude, and they are measured in something called dB, which comes from the pioneer Alexander Graham Bell. Yes, he also invented the telephone. So let's take a listen on how this works. So we're going to see it and we're going to hear it. So the first thing we're going to do is we're going to look at two different sound waves, the sine waveform and the square waveform. So this is on Spotify. I am going to play it for you right now. Okay, now it's your turn. How are you going to explore this? Well, we're going to use two different websites that you're going to have to sit there, listen, and even do some reading up on what's going on. The first thing you're going to do is go to Ableton Learning Synths. I'm going to post that in the comments so then you could access this link instantly. And now what it's going to do is going to go step by step on what we just talked about, and you're going to get to try it and hear it. So it starts with amplitude, but then we're going to go into more things and it's going to help you with future lessons. Then the second part is you're going to go to synthesizers, which is on Building Beats website, and I'm going to post that in the comments as well. And this is where you're going to be playing a synthesizer, which is kind of like a piano, but it uses electrical sounds and it moves it all different ways. And you could choose the different sound waves of how it's going to affect your sound. So if you play a C on the piano, what does the C on the piano sound like with waveform that is square? What does the C sound like with a sine waveform? And now with this next exercise that we're going to do now, I want you to figure out, okay, which one sounds louder to my human ear? But notice this, once we're on Spotify and I'm playing the sine wave and the square waveform, they are both playing the same pitch and they are both at the exact same dB level, okay? But what is going to happen once I hear this?